Now we come to the concept of error analysis. Now, error analysis actually involves the errors that we do during our study of various physical experiments. Now, you see, if you plot the number of errors versus time that you are having in your laboratory, then you have a normal distribution graph like this, which shows that a huge error is an unique and happens over only a particular time. But you can see very small errors having over a long span of time. So these are the errors that we are taking into consideration, and that is the reason why in error analysis we always add the errors. Now you see, this may sound odd, but what we do here actually is that in error analysis, if you are asked to add, you are adding a plus b. Now the point is that if you are subtracting a minus b, that will also result as addition. If you are dividing something, that will also result in addition. If you are multiplying something, that will also result in addition. So this is a major, what I say, mental stucking we face when you do error analysis, because till now we are subjected to a subtraction. While I see the sign of a minus b, I was ready to do an operation of division when I see a divided by b, and I was ready to multiply when I see an operation a into b. But now all these four should lead to addition. So that is the primary caution that I should give you, that here in error analysis you should always add the quantities. Well, now how? That let us come to that point, that how we should add them. Say I have a variable x which varies as a square, b cube and c square. And I am given that the error of measuring A is 1%, error of measuring B is 2%, and error of measuring C is again 3%. Now in error analysis, what we do initially in terms of mathematics, we say that we take on log on both sides and differentiate. But you see, this is an uphill task, that you log on both sides and differentiate. In other words, what we can do simply is put this as a relative error of del x by x, which is actually dx by x. And then what all you do is bring the power in front and multiply, bring the power in front and multiply, bring the power in front and multiply. What it comes to is 2 del a by a plus 3 del b by b, and then again plus, mind you, if it is in division, we have to add here. So it is plus 2 del c by c. Now this portion of del a by a as percentage is given as 1%. So it is 2 into 1. This del b by b is given as 2%. So it is 3 into 2. And then del c by c as 3%. So it is again 2 into 3. So what you have is 2 plus 6 plus 6. So that gives you a total error of 14%. So you see, the calculation is rather very simple if you go by this straightforward method of doing nothing but just multiplying the power here, multiplying the power here, multiplying the power here, and then you add them like this. Well, let us take me another example, and I will try, or I will make you to try this. Well, now I have x varies as a, varies as b square, and varying as root over of c. And I say that all a, b, c have an error of 2% each. So you just try whether you yourself can write it right now with me. So yes, are you writing del x by x? That's what should you write. You should write del a by a. Well, what you should write? 2 del b by b. You are absolutely right if you are putting it in this way. And what about c? I hope you know the power of root over is half. So you are absolutely right if you have put it in half del c by c. So those who haven't yet grasped it, I'll repeat for them that all you do here is multiply the power in front, add in irrespective of division and multiplication what you have, and then just put the values. Say A by A as percentage is given as 2, B by B as percentage is given as 2 again, so I'm adding it, and this is half into 2, so mind you it is half into 2, which becomes 1 actually. So now it is 2 plus 4 plus 1, so it is 7% that we have the error. So this is how you deal with the error analysis. Now I'll give you one more example and find out whether you have got the thing right or not. One last case, let us come to this. You do it and tell me, I have a value of A which varies as x squared, which varies as c cube, x having a percentage error of 1%, B having a percentage error of 2%, and C having a percentage error of 3%. Now I will do it just mentally. 2 into 1 plus 2 plus 3 into 3. You just check out whether you have been able to grasp it. It is 2 plus 2 plus 9. That gives me 13 to be precise. So it is 13% of error in A if I add these whole errors together. So now students, it is up to some physical quantities that you can deal with like this. Say you are given a relation between heat, H, current, resistance and time. And you are told that in order to measure the current, you have taken an error of 1%. In order to measure resistance, you have an error of 5%. And in order to measure time, you have an error of again 1%. So what will be your percentage error in calculation of heat? Well, I will again do it mentally, and I hope all of you will try doing it mentally, because this is very, very simple, plain and simple addition like this. So it is 8% error what I get in heating effect. So you can have actually in physics a particular physical relation, and then in that relation you will be given the errors and you operate like that. Well, I will give you another example and I will find out whether you are comfortable with this kind of relations or not. So let us now come to this relation where I have an error of voltage as 2%, error of time 2%, error of resistance 1%. So let me see whether you can directly put it or not mentally. It's 2 into 2 plus for T, it is again 2. And for resistance, don't make it -1. Please, for God's sake, make it +1, because as I've told you, any division will relate to addition. So it is 4 plus 2 plus 1. So now you are creating an error of about 7%. So this is how we are actually jotting down with errors and finding out the values. So there can be various physical quantities which you need to deal with, but all the patterns are same. Well, I will give you another example and check out whether you can do it directly or not. So this time I have an equation of a time period of a pendulum which is 2 pi root over L by G. And I tell you that measuring error measurement for L have an error of 2%. The error of measuring acceleration due to gravity is 2%. Find error in measuring the time period. So in that case, you have to remember that this is of no use to me in error analysis. I have to only consider L and G. And let me check whether you can again put it directly like me. So it is half into 2 plus again half, no minus half mind you, into 2. So that gives me 1 plus 1, 2% error in measurement of the time period. Well, friends, I hope it is clear to you. Go on doing more and more error analysis, the method we have just shown you. Thank you.